Hey guys, so in section 4, we're going to talk about and learn how to use the Pythagorean theorem. So you might have heard this before. We use it to solve for the side lengths of a right triangle. Okay, so you might have seen this a little bit before. You know that the formula for this, the theorem, is that if you have a right triangle, it only works for right triangles. Then you know that a squared plus b squared equals c squared. And that a, b, and c refer to the three side lengths of your right triangle. Okay, so you have to have a right triangle, you have to have a right angle, right? That's really important. And if that's the case, then the two legs, the two sides that create that right angle are a and b, and the side that's across from the right angle is called the hypotenuse. That's the c. Okay, so a squared plus b squared equals c squared. Okay, and the converse of that is also true. The converse just means basically the opposite theorem. Okay, so if you could show me that a squared plus b squared equals c squared, so the smallest side, the medium side, and the biggest side, then you could tell me that it's a right triangle. Okay, so I'll show you how it's going to apply to the problems. So this first one's pretty straightforward. We've got a right triangle here. We're going to find the length of the unknown side. Okay, so this is like A, this is like B, and then it's like C. A and B don't really matter which one's which, right? As long as it's two sides that create the right angle. C is really important. C has to be the biggest side, and it has to be the side that is not touching the right angle, so it's across the triangle from the right angle. Okay, so with that, we know we're going to use a squared plus b squared equals c squared. And we can plug in everything for a, b, and c. So x squared plus 9 squared equals 10 squared. Right, x squared we don't know, 9 squared we know is 81, and 10 squared we know is 100. So we just need to solve for x, get x by itself. So we can subtract that 81 over. And take the square root of both sides to get rid of our squared. And we're left with x equals square root of 19. And you could leave it just like that. You don't need to plug it in your calculator. In this problem, it's a little bit more complicated. Right, you have to draw the right triangle for the problem, based on what they say. So you've got a right triangle. Okay, it's got one leg that's 1 foot longer than the other leg. So that means that one of these is x, and the other one's 1 more than that. So x plus 1. The hypotenuse is square root of 13. Remember, hypotenuse is across from the right angle. We're going to try to find the unknown lengths, those two legs. Okay, so we have an a b, and a c. So we have a squared plus b squared equals c squared. A equals x. B is, this is really important, parentheses x plus 1 squared, okay, because the entire x plus 1 needs to be squared, equals square root of 13 squared. Okay, so x squared is really, really easy to work with. You just leave it as x squared. Now this right here, our x plus 1 squared, remember, we have to FOIL that out. You can't just distribute power like that. You have to have x plus 1 times x plus 1 and FOIL it. So when you do that, you'll get x squared plus 2x plus 1. Okay, and square root of 13 squared, the squared and the square root just cancel each other out, and you're left with 13. Okay, so we can get all the x's together. You combine these like terms. So we have 2x squared plus 2x. Now, because we have an x squared and an x term, we probably want to get everything to one side, because it's going to be a quadratic. So subtract the 13 over, so we'll have a minus 12 equals 0. You can divide everything by 2, because they're all divisible by 2. So x squared plus x minus 6 equals 0. And from there we can factor. Okay, so x squared plus x minus 6, we do two things: to multiply to negative 6 and add to positive 1. So x plus 3 times x minus 2 equals 0. That's how you factor it, because 3 times negative 2 is negative 6, and 3x minus 2x is positive x. And from here, I've got x equals negative 3, or x equals 2. Right? But negative 3 doesn't make any sense, because you can't have a negative length to create a triangle. It's got to be x equals 2. Okay, so you can plug x equals 2 back in, and you'll get 2 for this side and 3 for that side. Okay, so those will be our unknown lengths, 2 and 3. Okay, number 3, we've got a rectangle. It's 18 by 20. And they want to know what the diagonal of the rectangle is. So a diagonal is going to cut right through it from corner to corner. Right? Obviously rectangles have right angles. So we're going to be trying to find C. We've got A and we've got B. So we could do 8 squared plus 20 squared equals C squared, where C is the diagonal. So you got to work these out. We've got 18 squared is 324. 20 squared is 400 and equals C squared. So add them up and we'll have 724 equals C squared. Take the square root of that, and C is approximately 26.9 feet. Okay, so that's the length of the diameter, or diagonal, sorry. And number 4 and 5, we're going to work the opposite direction. Okay, so we've been working so far. I've given you the right triangle, and you find the side lengths. Now what we're going to do is I'm going to give you the side lengths, all 3 of them, and you're going to plug them into the Pythagorean theorem and see if it works out to let me know if it's a right triangle or not. So the smallest one's always going to be A, medium one's B, biggest one's C. Alright, it's not necessarily always in order like that. In these two it is, but 24 could come first. It still would be C. Alright, so what we need to do is we need to plug this in. A squared plus B squared and C squared. Okay, so we've got 7 squared plus 23 squared. We want to know, is it equal to 24 squared? Okay, so you could use your calculator if you don't know these square roots off the top of your head. 7 squared is 49. We should know that one. 23 squared is 529. And 24 squared is 576. Okay, so we add these up. 49 plus 529. You get 578 equals 576. Is that true? Nope, it's not true, so it's not a right triangle. Right, and lastly here, number 5, we've got 5, 12, and 13 are our lengths. So we've got 5 squared plus 12 squared equals 13 squared. So we have 25 plus 144 equals 169. Add these up, and you get 169 equals 169. That is true, so the answer is yes, it is a right triangle. And that's all we're going to do with the Pythagorean theorem in this section.